Everybody, welcome back to the channel. This is, I believe, day 5 of the disassembly of Caterpillar D2 number 5J2115SP. I apologize for the scarcity of videos lately, but with everything Mother Nature's been throwing at us and snow removal and demands from work and cold weather, and I've spent the last 3 days clearing snow from every roof here on the property. Firewood's finally done. I'm so tired I'm ready to tip over, but we're going to get a good start on getting this thing torn the rest of the way down here tonight. I'll get a few parts ripped out of it and go until I can't anymore, and then we'll pick back up tomorrow night. So enough talking, let's get started. I'm not going to get too in-depth with this since it's all the same steps that I already performed on 5J number 1113. But I'm going to start by getting this pickup tube and front suction bell off of here, and this one looks a lot better than what came out of 1113. If you watched the disassembly videos of that engine, you'll remember it had water in the sump, and water got in this tube, froze, and heaved it completely out of the front adapter piece here. So this would be a very suitable replacement for that broken tube, so I don't have to fix that other one. I can just do a direct bolt-in replacement with this. Wait a second here. There we go. It was just that tight. Thought I was turning it backwards there for a minute. Like I say, kind of been putting in some long days lately. Kind of been a little short on sleep, but starting to get goofy. There. Both ends free. Get it out of the way. And I folded over the barely in place fold over locks on the front bell here. At least they seem to have got all the bolts tight. They did a much better job of that than they did securing them. There, last bolt loose. Give it a little bit of a look over. I mentioned in the 1113 disassembly how I just really like the construction of these. This is all like a cast brass, some nice machining in there. This screen looks like hand soldered on, and this looks again better than what come out of 1113. That engine had this screen heaved off, and this solder joint was broken a bit because of the water that had gotten there and froze. So I think this is yet another piece that's going to go back into 1113's engine. It's in a lot better shape. Oil pump will come off next, and I'm just taking the actual pump unit off of the drive base. So there's only 3 bolts here that have to be removed. That one right there, one at the back, and one on this side here. Yep, break the gasket seal. It'll come out of there. Come on. There we go. Should come right off. Yep. It's driven by this slotted tang right here. Oil pump drive unit comes off now. I want to get that out so it disengages from the cam. But first I have to get those locks, those little tabs, folded down. And for some reason, I don't know what it is, I just really like these old engines with these old fold-over lock tabs. I think it's just the hand-fitting aspect of it where, you know, you just don't see that anymore. I work in the Ford dealership, do a lot of the modern diesel stuff, and those engines are, I mean, they run very well when they're running well. When they don't, they're an absolute nightmare. But you just don't see anything inside those that's just as cool as these. You know, I don't know what it is. I can't really explain it. Granted, everything's more fun when you don't have to do it, so that's probably why I like these. If I had to work on these old engines for a living every day, I'd probably, you know, crave the new stuff. I don't know, but I don't see anything with the new stuff that really impresses me that much. And I certainly don't see anything in the new era stuff that looks like it's still going to be around when it's 80 plus years old and still be running. In fact, I know for a fact it isn't going to. Get that moving. I think that's got a gasket under it too. Yep. It is a tight fit. Of course, I don't know how much crankcase sludge is under that. Plenty of stuff holding it in. There, we got it moving. Oh yeah, look at that. Look at all that stuff. That is why it didn't want to come out. Oh man. Yeah. Nice, let me tell you. And again, if you guys watch the 1113 disassembly, you know the routine by now. Remove idler gear, which isolates the entire gear train. I can now turn this cam around and access the fold-over lock and the bolt here, and the fold-over lock and the bolt on the other side. Unbolt that thrust plate, and that'll come out. There's one. And two. Okay, let's rip this cam out of here. See how that goes. Not too worried about trying to save cam bearings and everything else. I'm sure they're bad just like the rest of it. But we won't just beat on it either. Definitely seems like the farther I get into this engine, the more of this black grime I find. So although I changed oil on it regularly when I was running it, it looks like it had a lot of hours put on with not a lot of maintenance at some point in its life. So the crankcase was fairly clean, and I'm sure that's because that gets washed out with, turbulence in the oil and everything else. But you get to these lower flow areas, like around this oil pump drive gear, even that detergent oil I was running was not able to get in here and really scour those parts as well as I would have liked. Next up now is the idler gear hub and the accessory shaft. Same deal. Take and fold the lock tabs back, and then remove the fasteners. Three on the idler gear hub, and there's going to be 3 under the accessory shaft gear. You just wheel the open holes around in the gear until there's 1. Go down here. There's 2. Wheel it up around here, and there's like 3 like right there. So that's how those come out. There we go. At this point now there's just 8 bolts holding this intermediate cover on, and that's the piece that I'm going to take off next. So you got 1 down here, 2 on the other side. Don't forget those because they can kind of be hidden. Here's 3. Now we have 4, 5 in that corner, 6 in that corner, 7 below it, and number 8 right here. Now we see if the cover will loosen up. Oh yeah, this one loosened up nicely. Well, good thing that gasket was old. It didn't have a lot of stick left to it, huh? That's probably about the easiest one of these has ever come loose for me. Okay guys, we're about ready to finally start seeing some good stuff here. We're going to start pulling some pistons out next. Now I've said this once before, but I'll say it again. These connecting rod ends are so big that they will not go through the cylinder bore. They are actually bigger than the diameter of the piston, so these piston and rod assemblies have to come out the bottom of the engine this way. You can also get these pistons out without removing the crankshaft first. You can manipulate the piston skirt past the crank throw. So I'll show you how it's done here. And I do plan on measuring all the bearing stayed on the crankshaft there. I was like, what? I do plan on measuring what the running clearance is on these two, just out of curiosity. But let's have a look at this. That is an all aluminum bearing, no Babbitt in there, and she's scoured some debris around. You can tell by all those scoring lines in there. And that crank journal is anything but smooth. Make sure I get this put back in the way it came out. I'll disengage this from the crank journal. Get it pulled up around. Start the rod out. You can hear some rings clicking past a slight groove that's on the bottom of the sleeve, which you usually don't have large wear grooves down here. There we got the piston loose, and with the crank throw positioned over to this side, you should be able to take it right out. Yep, just like that. Okay, let's look at that piston we just pulled out of there. Really, the wrist pin feels a lot better than I thought it would. Not a lot for play there, but we've got some profound side clearance on these rings. I've never had rings move around like that, especially this top compression ring. And these are those 2-piece pistons that I mentioned in one of the earlier videos, because if you saw, what was it, day 2 or 3 on this, I can't remember now, number 4 has this outer ring loosening up. You can just, hopefully in the light off the end of my finger, see just a faint line around there. That's where we have this steel portion right here that goes around the top ring. You can see it's somewhat discolored from the rest of the piston, and it'll stick a magnet right to it. But then you have, so you got steel there, just above it, here we got aluminum, and the whole top is aluminum. So we've got this steel segment here around the top ring, and then the aluminum bodied center, and this outer portion is like a nut that's also made of aluminum, threads down, sandwiches this steel portion that holds the top ring and takes the brunt of the wear from the compression. And I believe that round indentation there and this round one here is where this basically nut portion at the top is actually pinned onto the rest of the piston body, keeping it from loosening up. But as we'll see with number 4, that didn't always keep these secure. Sometimes, well, a lot of times they did end up coming apart. So have some scuffing on it, which is kind of to be expected on these, such a high hour machine. But don't know that these pistons would be reusable without tightening up those ring grooves or milling them out wider and getting some wider rings to fit. But we'll see what the rest of them look like. Okay guys, sorry for that little break in the action, but it's actually the following day. After I got that piston and rod assembly out, I was just too dang tired and I just had to quit. So another day, as you can tell, it's snowing again. Got this stuff all over me, but let's get those other 3 pistons out of there. So I've got the crankshaft positioned to get number 2 and number 3 out. And I might take this time to apologize if I seemed a bit dopey last night. I was pretty well wiped out after the last few days, and I'm pretty monotone on a good day, so I can only imagine what I sounded like last night. Don't even really remember how much I talked. Just kind of out of it. Probably shouldn't have even been in the shop, but you know, had to come out here, try and get something done anyway. There we go, number 2, rod cap off, bearing looks much the same. Yep, 3's right off of there. Shell stays on the crank again. And again, much the same. They don't look, oh yeah, they were starting to work a little bit in the caps, loosening on the dowels. Kind of to be expected. Again, drop number 2 out of the way. Same for 3. Just make sure that crank's positioned to the side and give them a pull. Pull empty of room. Let's do a quick assessment here. Well, control rings are about as worn, and same side clearance on the compression rings. Again, wrist pins just are not horrible on these. That kind of surprises me. And pull number 3. Just another quick check. Again, about the same. Got some pretty good scuffing going on that one. Pretty good score marks. It's like she was running just a bit dry. Ooh, look at that. That's even worse. It even pulled some material down here to the skirt. That one got a little bit dry. All right, number 4 is the last one left. That's going to be the main event. That's that piston that's coming apart. I'm kind of excited to see that one, but I want to show you something. Just how loose this engine is. You can get, just so you start lifting number 4, let go of the crank, and it just goes, just falls right back down. Just horrendously loose engine. If that was a new piston with new rings and a new cylinder, you'd have to forcibly move that. Instead, it just falls down just from its own weight. So, can't believe this engine had much of the original compression left in it. Okay, number 4 coming out. Last one. There we go. Have a little bit of a look here. Oh yeah, I can make that whole insert spin right around that top ring is in. That's that whole steel section right there. That thing had to have been migrating around when this was running. Scary, I tell you what, just scary the way that was coming apart like that. Now let's get this crankshaft out of here. Pulling this rear main bearing cap. I won't go into too much detail with it because I broke it down pretty well when I was disassembling old 1113. I will say though, this is the most tedious step, having to pull this cap. The rest you can just pull off by hand. And again, like I said, the rest of these main bearing caps can be pulled by hand. No special pullers needed. You do want to make sure you get all these caps back in the same spots that they came out of and facing the correct direction. You don't want to have them get turned 180 and reinstalled like that. That will cause bearing misalignment. If they're not already numbered, you can punch mark identify them, or if you have number stamps, you can stamp 1 and then 1 on the block, 2 to orient them correctly. What I usually do is just jot things down in a notebook instead of stamping. So for location identification, the rear main's pretty easy to remember. It's a big monster one. It only fits in this one spot and can only go in one way, so that's no big deal. Number 1 is unique in its dimension, and just make sure the casting number faces forward. That is exactly the way it was installed. We have number 2 main cap and number 4 main cap, which are identical in dimensions, so just make sure they get set in the proper sequence. And again, casting numbers on all these face forward, so if you put all these back in the proper sequence, you cannot have a problem. The center thrust bearing, again, is dimensionally unique. Just make sure you have the casting number facing forward. You'll be good there too. Now finally, crankshaft can come out. And like I stated earlier, we don't exactly have polished journals anymore. Quite a lot of scoring and wear on there. I want to show you this right down here. You see that silver stuff? That is from the main bearings starting to lose their babbitt. Got one here that had shelled quite a bit out. This rear main has a big piece that was just loose in there. So that's what a lot of those silvery flakes were in that oil pan. And real quick here, I know I said earlier that I'd do a check to see what the running clearance on some of these rod bearings were, because one of the prior videos when I was tearing this down, I could grab a hold of these rods and actually hear an audible click on the crankshaft. I did just a very rough measurement with this caliper. We're not going for precision here. I just needed a ballpark figure, and I tell you what, it's kind of astounding. The mains on the crankshaft are not that bad. They're really not that out of round. They're wore down about 5 thousandths, and I had about a 15 thousandths running clearance, which is just out of spec on those. I think perhaps up to 12, I think, was maximum allowable spec. But I had 15 thousandths out of round wear on the rod journals, which 13 thousandths clearance on rod journals is maximum. So I had more than the maximum permissible clearance just out of round wear on the rod journals. And when I did a quick check of bearing diameter, my average running clearance on these 4 rods was 35 thousandths of an inch. And honestly, guys, this thing didn't knock. It held decent oil pressure, except for when it was at a hot idle, but number 3 was my worst one with a full 40 thousandths running clearance. Pretty astounding considering this thing still ran and had, you know, reasonable power, held pressure, didn't knock. So this is as far as I'm going to go tonight. My next step is to get this block flipped over, clean those sawhorses off, place it up on there, and pull those sleeves out of there. But I want to make a separate video, kind of a how-to video about that, showing how I pull sleeves on a Caterpillar D2 block. So I'm just going to do another quick video showing that, and then we'll start cleaning that thing up. Hopefully find that we have something worth salvaging there. Hopefully it's worth rebuilding. So guys, as always, thanks for watching. Hope to see you back next time.